Hey, what's going on? My name is Harrison, and this is going to be an Unreal Engine 4 C++ tutorial on UIs and health bars. Let's go ahead and jump into the final product. This will probably be a very long video, so let's get started as soon as possible. I'm going to go ahead and click F11 to go full screen. Alt P to play. So immediately when we start playing, we can see in the top left that we have a health bar, and what I'm going to call is a magic bar right above it. That's the blue bar. So the red bar, well, first, you can probably see that I'm mimicking the Witcher 3's health bar, and that's just for aesthetics, and that's just for fun. The images that I'm using for the health bars will be in the description below. So we have the red health bar, and then we have the blue magic bar right above it. As soon as I shoot the gun, the magic bar will go down. My gun will change materials, kind of indicating that the gun is overheating, and then I can't shoot again for another 2 seconds. So I can't shoot for another 2 seconds. But you can see that the magic bar is smoothly decreasing along with the numbers. They're decreasing as well. And so I'm going to shoot until I get to 0. I can't shoot again, but in 5 seconds I'm going to go right back up to 100. And boom, there we go. Now we can start shooting again. Or I can intercept whenever it's going back up at any time as well. So now let's jump into the health bar. The fire right now is the only thing in the game that can damage me. It has an apply point damage method that will trigger the character's receive point damage function. So let's go ahead and trigger it. And you'll also see that as soon as I get hit, there'll be a red flash. And in this game, we have a 2 seconds of invincibility. So we cannot get hit for another 2 seconds. So we're getting hit. We're getting the red flash animation. Since I'm still in the fire, the hits are still going. Again, I walk out. I can walk through the fire as much as I want, and I'll only get hit once because I have that 2 seconds of invincibility. As soon as I walk into the fire and I hit 0, I'm then just going to restart the level. So now the level restarts. So again, we're getting hit, we're firing, and then we have these red medkits that will give us more health. And right now they're giving us 10%. So now we're back at 100. My magic meter should refill. I'll stop that in progress. I'll get some more health. And now let's just kill me off and restart from 0. So this will be the final product. So let me jump into a fresh project and we'll recreate it in C++. Also, we will be jumping into blueprints very quickly just to bind a couple of UI functions or UI variables to some C++ functions. But again, I promise we'll jump in and jump right out as quickly as possible. Alright, so I just created a fresh project. This is using the standard C++ first person template, and I am using starter content. I'll be using definitely the fire particle effects from the starter content to create my campfire effect, or kind of thing that will apply damage. Also, there should always be a link to the GitHub repo down below, which should have all the code. So if you just want to grab the code and move along, you definitely can. But let's go ahead and recreate the UI and everything else in a fresh project. Since we'll be using the UI, first let's go ahead and update our build script. I'm going to open up Visual Studio Code. This is my text editor or IDE of choice. If you use Visual Studio, totally cool. Jump into the build file, build.cs, and we're going to add in the UMG elements. So it's UMG, Slate, and Slate Core. Save that, close that. That will be all we do in that file. Okay, now let's jump into the character file. The character will be doing a bulk of the work, and everything else will kind of follow suit after the character is done. Alright, so jumping into the character's header file, mine is called cpp character.h. The first thing we want to do is include the timeline component, because we'll be using timelines for the magic bar. That's components, /timeline component.h. Now let's scroll down. Right here in this protected section, we're overriding, or we're at least taking the begin play function. We're going to want to override the tick function here. How do we do it? virtual void tick we'll be using the tick function in the character, so we'll definitely need it. Now I think we're going to scroll down to the end of the public section and start adding in all of our variables, and we're going to have a lot for this guy. U property, edit anywhere, blueprint readable, blueprint read write, and then category equals health. And we're going to have 1 for full health. And it's going to be a float. I just want to make sure that's correct because I'll be copying it a lot. Blueprint read write. That sounds right. Alright. We're going to copy that and probably use that throughout most of the properties that we use. Float health percentage. This will keep track of the health percentage. Let's do the same for magic. We're going to want to float for full magic. And then a float for magic percentage. Oops. I think we'll also want to keep track of the previous magic's percentage so we can smoothly transition between two values. Previous magic, I believe. We're also going to make a value for how much magic we're using. That's how much we'll decrease the magic by. Next, we're going to create a bool for the red flash, and that'll determine if we want to show the red flash or not. What's next? Next, we're going to do a U curve float. That will be the magic curve, and that will allow us to smoothly transition between two values for a smooth transition. What's next? We also need to create a timeline. We'll just call it my timeline. Get rid of this for the timeline. Get rid of this as well. These will belong to the magic category. F timer handler. Handle or handler? Handle. We'll just call it member timer handle. Alright, so we have two of these going, right? This will be called magic timer handle. So both of these will serve two different purposes. One will be 2 seconds, which will be the amount of time we can shoot, or 2 seconds to determine the interval between when we can shoot, and the other one will be the 5 seconds of waiting time until it refills the health bar, or the magic bar rather. So they'll both serve different purposes. Float, another float, bool. I need to put my semicolons there. Other values we'll track to determine other logic. Blueprint pure. It's a U function, blueprint pure, and we'll add it to the health category. And this will be what we bind to our UI element to determine what should show, how much percentage it should show for the health bar. It's another float. No. This will be ftext. Get health and text. This will return the number value or the percentage as a number, as a text value, so the UI can read it. And we'll do the same thing for magic. Yeah. So I'm just going to copy and paste them and change the values. That should work. Another U function. What's this one going to be? Void damage timer. This one will just, you know, I believe it's going to start the 2 seconds for invincibility. U function void set damage state. I'm just going to copy it. Void set magic value. Void set magic state. Set magic change, and this will take a float parameter of the value being passed through. Oh shoot. Void update magic. We're going to be calling on this one from blueprint, so let's make it a blueprint pure. Is that right? Yeah. This can also go in the health category. And it will be a function to whether or not to play the red flash animation that we'll create later. Alright, a couple more properties. Edit anywhere. Class UMaterial interface. Pointer. Gun default material, and we're going to do the same thing for the overheat material. Gun overheat material. Now we're going to set up probably one of the most important functions in this tutorial, and that's going to be the ReceivePointDamage function. It has to be a U function. Let's go ahead and set it up. Void ReceivePointDamage. This will trigger every time point damage is applied. Takes one, float damage, const DamageType, pointer DamageType, FVector HitLocation, FVector HitNormal, UPrimitiveComponent, pointer HitComponent, takes in a BoneName, FName, BoneName, FVector, ShotFromDirection, AController, pointer, InstigatedBy, he started the hit, takes in the causer, no, it's AActor, pointer, DamageCauser, and then finally FHitResult, a reference to the HitInfo. Semicolon. Alright, so that's the ReceivePointDamage function. Let's finish off the header file with the update health. Let's just put that up above. Where do I put it? Whatever. U function. Blueprint callable, category, health. Void update health. And it takes in the value you want to change the health by. Alright, so that should be it for the header function. Now we'll jump into the Cpp file and start connecting all these variables and functions and get the character going as soon as possible. Alright, now into the Cpp file. Here at the very bottom, let's include a couple things. We're going to include the Kismet library. Kismet, all lowercase. Kismet math library. Now we need the time library. Include time manager. Should be good there. I don't think we're doing anything inside the constructor function. I'm just going to double check. I think we're going to do all of our logic in the begin play. Again, this stuff can probably be done the constructor function as well, but just for a tutorial to make things go a little bit quicker, we'll do it in the begin play function. Alright, so full health we're going to set at 1000.f, right? So it's a float. It's a float because we're going to be doing some math on it to get the percentage from it. We'll convert it to an integer when we need to. And so we need the full health. This number can always be changed, and it'll change, you know, if you want to apply armor or apply some kind of buff, then this full health can go up, then the damage you receive will be less, and it will translate into a less of a percentage decrease for the health bar. Our health will equal full health at the beginning of the game. Health percentage will equal 1, as in 100%. B can be damaged. is true. It might default to true. B can be damaged is a function that, or is a property that every actor has. Now let's see the same thing for magic. Full magic will be 100. And our current magic, which we're just calling magic, will equal full magic at the beginning of the game. Magic percentage, that will equal 1 to represent 100%. Our previous magic will equal magic percentage, so we know when to start when we start decreasing it. So for a smooth transition. Magic value will just default to 0 because we're not using any magic right now. B can use magic. It's just a bool that will set to true at the beginning of the game. Let's set up our magic curve. If magic curve is true, because we'll drag it in the editor when we create it and then apply it to the character. F on timeline float, timeline callback, F on timeline event static, timeline finished callback, bind UFUNCTION. What's the function's name? We'll create it later, but the function will be called set magic value. Timeline finished callback. Another bind UFUNCTION. This FName. Text set magic state. Oh, I don't think I need the text here. Just call it set magic state. There we go. My timeline add interp float. Let me just see if I spelled that correctly. This will run on the magic curve. Magic curve. Timeline callback. Set timeline finished func. This will be the timeline finished callback. Just making sure everything's spelled correctly to reduce errors. Yeah, so the timeline is going to run the set magic value each iteration of the timeline, and then when the timeline is finished, it will run the callback of set magic state. I think that's it for the begin play function. We're not doing anything in the input component function. We will be changing up the OnFire function though. Oh, you know what? We need to call the tick function. Let's just do that right after begin play. Void a Cpp tuts character tick float delta time, right? We're gonna want a super tick delta time, and this is where you have to connect your timeline, so it's aware of the tick, so it runs properly. Has to be aware of frames per second. or the time between frames. Is that all right? All right, sounds good. Let's go ahead and jump to the OnFire function. All right. So since this game is a little different and we're kind of just doing this for practice and for examples, we only want to fire the gun if we can use magic and if we have some magic left. So that could be, I mean, this could also be interpreted as a gun that overheats or maybe a shotgun or something like that. But again, for this tutorial, let's just continue calling it magic and just pretend like it's a magic gun or something like that. So OnFire, if we have the projectile class, if it's not null, don't fire. But also, we're going to do fmath is nearly 0 magic 001f. I'll go over that in just a second. And B can use magic. So one, we're checking to see if the magic value is above 0. We're using the fmath function is nearly 0 because Unreal can be very specific. So we're just gonna say if magic is close to 0 and it's within 0.001%. So pretty much is it 0. I ran into some problems by kind of saying if it was below 0 or is 0 or some things like that. So anyways, is nearly 0 was a helpful function that I decided to use for this situation. And then I am using B can use magic to make sure that we are within, that we just didn't use the gun, right? Because there's that 2-second interval where we can't use the gun because it is overheating. So basically B can use magic is kind of indicating, is the gun overheating right now or not? So pretty much everything in this function is going to be wrapped in it. We're going to put these two if functions inside it as well. So I'm just going to go ahead and copy and paste them and put them inside the curly brace above it. So right after all of that, let's run our magic stuff. Immediately, we're going to stop the timeline if it's already moving. So we don't want it to run twice. Get world time manager, clear timer, magic timer handle. Also, we're going to clear the magic timer handle because we want to restart the 5 seconds that will then give us more magic later. We're going to run the sat magic change function, decrease magic by 20 points. Get world timer manager. We're going to set a timer. The magic timer handle is going to be on this actor and reference update magic. Okay, a Cpp touch character update magic. Nope. That's good, and we want it to run after 5 seconds, and we do not want it to loop, so we put false. So you can see why we're clearing it and why we're starting it again. We're stopping the timeline because we're going to start it again. I believe we're going to start it again in this function. And again, that's just to prevent it from rerunning and just causing other conflicts. Alright, I think we can just go to the very end of the function or the end of the script and start writing some of our own stuff. Float a Cpp tuts character, and this is going to be get health. I'm going to copy this real quick so I don't have to, hopefully I remember. And this is going to simply return health percentage. And this is what's going to be, well, we're going to bind this function to the UI element. So the UI element always checks this function. I believe it checks it every tick. So the UI health bar and magic bar can respectfully display how much health bar percent to show. Poorly worded, but just that was what's telling how much health we have to the UI. Get magic, return magic percentage. And now it gets a little more difficult for when you're dealing with UI text. I think I'm calling these get, I call this get health int text. Alright, so we're going to do, let me get this up here. Nope. Int 32 HP equals fmath round half from 0 health percentage times 100. Alright, so we're getting the integer, we're getting the percentage, which is a float, times it by 100 so we can get that value as an int. F string HPS. Now we're going to have to convert it to a string. And it's going to be F string from int, that's going to be HP. That's the int we're passing through. Another F string, which will be health HUD, equals HPS plus F string. And we're going to pass in the value of a percent sign to show percentage. Again, not necessary for a real game, but it's good for practice. F text HP text equals F text from string health HUD. So now we're converting the string to an F text element. So now we can finally return HP text, and this is what tells the UI, or it allows the UI to read this value. Now we're going to do something very similar for magic. I'm just going to copy it, change up some values. This will be magic percentage. I guess we don't have to change up the variables, but good practice too. Because these variables will be local, I believe. Magic. I'm doing one different thing here though. Alright, magic HUD. I think I also want full. So we're going to do full string. That's going to be full PS, and that's going to be an F string from int. That's going to be full magic because we want to display this as well. That'd be a good indicator to see how much magic a person can have. That's going to be MPS plus text. We're going to do this a slash, and then we're going to add on full MPS. A little bit different, but still very similar to the health integer text function. Alright, I think that should be good. Let's move on. Void a set damage state. B can be damaged. That's true. This is just going to run after 2 seconds, telling the character, or telling the game that the character can now be damaged, because again we are changing it to false after we get hit, waiting 2 seconds, and then turning it back to true. Damage timer. Get world timer manager. Set timer. Member timer handle. This reference the Cpp text character. Set damage state. I set damage state. Yeah, that's correct. Run it after 2 seconds and do not loop. All right, now let's set the magic value. Yeah, there's so many functions. Cpp text character. Timeline value equals my timeline dot get playback position, right? Playback position. Curve float value, that's going to equal the previous magic plus magic value times magic value curve, I believe, right? Magic curve. And that's from our timeline, and we're going to get the float value from it. And our timeline is going to be going from 0 to 1 in 2 seconds. Get float. Get float value. So as the timeline moves, we're getting the float value at its playback position. We're gonna set the value of magic here and also clamp it so it doesn't go above 0, or so it doesn't go below 0 or above its full magic limit. So again, if your character levels up, full magic will go up, allowing the magic value to go up with it, and thus vice versa. So if you only can have 50 magic, it doesn't allow him to go up to 100 or 150 or 200. Clamps that value down. Magic percentage equals the curve float value. And we're also gonna clamp this as well. And we're clamping it so it's in between 0 and 1, thus 0 and 100%. Now let's set magic state. Cpp text character, set magic state, no params. We're setting it back to true. This function is running right after the timeline ends, so now we can use magic again. The magic value, this is indicating the value on how much magic we're using. We're going to set it back to 0. And we're going to change the material of the gun back to its regular state and not the overheating glowing red material. Set material. Yeah, and we first check to see if the material is true, so we don't run a function that will crash the game. Void a Cpp tuts, your character. Play flash. So in our UI, we're always checking to see if red flash is true, and if it is true, we're gonna play the animation, but the animation's 2 seconds. We don't want the animation to loop, nor do we want the animation to start over and over and over just because the value is true. Then it'll never get through the animation. So one, we're checking to see if it's true, then immediately turning it back to false. And now we're telling the UI, yes, there's a true value here, run your animation, and then we'll come back later. So if red flash is ever true, we'll return true. If not, we're going to return false. And we'll set flash, I think, in the ReceivePointDamage function. And that, oh, it's actually the next function we're going to do. Okay. Void a Cpp character. I'm going to copy the signature from the header file. Alright, so B can be damaged is false. So we can't get hit again until that's turned true. This function will immediately run when it interacts with a actor that is using the ApplyPointDamage function. Red flash equals true. So again, the UI will be listening to see when that red flash value is true, then immediately run the function or run the animation. And we'll do that later. We're going to run the update health function, and we're going to decrease health by damage. This damage value that we pass in as a parameter is coming in from right here, and the damaging actor will be passing in that function. We'll be passing in that value, that float value. And the damage timer is starting the invincibility timer, which will then turn B can be damaged true after 2 seconds. Let's do the update health function. Void a Cpp tuts character. Update health. It takes a float, right? Yeah, float, health change. Health change. What are we doing? So health is going to add the parameter of health change to it, whether that's a negative or positive value. We're going to immediately clamp health so we don't go above 100, or I mean past its full health limit. Clamp health and full health. percentage is going to equal health divided by full health. And that's kind of why we needed health to be a float, so we can do this. So we can always run this function without problems. You know, yeah, I'm sure there's ways around it, but easy enough. Let's do the update magic function. Void a cpp tuts. Update magic. Full magic. Equals 1. My timeline dot play from start. Nope. Update magic. This is gonna run to fill up the health bar after 5 seconds. Are we using this? We do not have a parameter here. On set magic change, we will have that parameter. So a void a cpp tuts set magic change. Right up here, the magic value is 1 because we're going back up to 100%. And in magic change, we're going to do B can use magic. No, we can't use magic because we just used it. What is what we're indicating? Previous magic equals magic percentage. Magic value equals magic change divided by full magic. So one getting the percentage on what it should change by. So if your full magic bar increases, then it will take less magic to do the same action. Magic change. If gun overheat material. So 1, if we correctly applied it to our character. Set material. Make it the first material, make it gun overheat material. And then start the timeline. Alright. That should be it for the character. I'm going to save it. I'm going to compile it, see if there's any errors, and then there's probably going to be some errors. But then we'll reattack it, fix it up, and then go from there. Alright, we got some compile errors. Let's look at these. Oh shoot, if I only have one, I'm gonna go crazy. Only having one error, especially if it's just a semicolon. Oh no, I'm missing a bunch of semicolons. Alright, let's recompile, see what happens. Alright, a magic value cannot be defined in set magic as already defined scope. This shouldn't be magic value, this should be magic change, I believe. Alright, missing a parameter list. A parentheses. You know what? Let's just get the function from the documentation. ReceivePointDamage. I'll put this link in the description below. I think I missed a parameter there. Let's try it. Alright, we got some errors. We're in the Cpp file this time. Oh, no such library. Alright, that must just be a typo. That sucks. Damn it. There's no T there. Kismet library, right? Alright, save it, recompile. Cannot include time manager, no such file exists. Alright, did I mess this one up too? It's not time manager, it's timer manager. Alright, here we go. Now we got all the freaking errors. This is undefined. Do we not set health in our header file? Alright. Just copy that and make it health. Did I not do magic either? Or what's? Yeah, I must have just overlooked those. Alright, my fault. Full magic, do another one called magic. Compile. Magic percentage, is it a typo? Percentage. Get world time manager identifier not found. Alright. Get world. Is it timer manager? I would assume, but let me double check. It's not on fire. Alright, F text not. Lowercase that, this would be the same. We're knocking them down slowly but surely. HP text is undefined. What's this? Yeah. My fault. My fault. Where's this one at? F match. Definitely not F match, but F math. Magic percentage. This is another typo. Alright, play flash void. Oh, because it's not a void function, it's a bool function. It returns a bool. I know before it's going to start compiling, but my signature right here is going to be wrong as well. I'm just going to grab all these from the proper signature and then paste them in. Uh, 412. Alright, 420. Update health is not a member. Alright, so I must not have. I think it's a capital H. And we got a successful compile. Alright, let's jump into the game mode file. This one should be quicker, but this will set up the game logic for our game. Alright. Do we need anything? Yes. We're going to include the character, so we can find the character, get his health, and then play off of it. What's my guy called? Cpp Tuts character. That's it for that. Then we're going to set up a enum class. It's going to be a uenum. Class e gameplay state. Is the character playing? Is it game over? Or is it unknown? Alright. Let's jump to the public section. Virtual void begin play. Spell it right. Begin play. We're going to override that one. Same thing for tick. Virtual void. Tick float delta time. Override it. A CPP tuts character. We're going to use that as a pointer, call it my character. UFUNCTION, blueprint pure. E gameplay state. Get current state will be constant. Void set current state, and that's going to take the parameter of e gameplay state. New state. Make a private section. E gameplay state, current state. Void handle new state. E gameplay state new state. Alright, that should be good for there. Now let's jump into the CPP file and set up the logic for our game mode. Alright, not too much going on right now, but let's add to it. Do I need anything? I don't need the constructor. I need gameplay statics. So we'll go hashtag include Kismet gameplay statics.h. I think that's it. Let's go further. Wait, player plan. We're not going to do anything in the constructor, so we're going to immediately jump into the begin play. Okay, what's this called? CPP CPP tuts game mode. Super this bad boy. Set current state. So as soon as we begin play, we want to set the gameplay state to playing, because you're playing the damn game. My character equals cast ACPP tut character U gameplay statics get player pawn this game player 0. So as soon as we begin the play, we're setting my character to the first player we can find, or basically player 1. And we're doing this in begin play, so now we can always cache this character, so I don't think we ever have to go looking for him again. So again, depending on the game, that logic will probably change. But for this simple, one player game, I think we're okay. Now we're going to jump into the tick function. Cpp tuts game mode. One second. Tick and delta time. Get world, get map name. You know what, this should probably be cached up in begin play, so we don't have to do this every frame. I think that's a waste, but okay for now. Let it be. But every tick we do want to check to see, one, do we have the character? Were we successful in casting to that character? That may be why you want to do this in the tick function, or do the cast in the tick function to always make sure you have them. But for this case, I think we're okay. So, you know what? This might be a typo. We might. Yeah, that's a typo. Get rid of that. My fault. So if my character, if we were successful in casting to the character, then also, if his health is nearly 0, I'm using the nearly 0 function again because Unreal can kind of go very in depth with their percentages. So I just want to make sure this kind of prevents some logic from not happening that we want. Get health 0.001. So basically, is the character's health at 0, or if it's at, or is it at least within 0.001%? Or no, that's 0.1%, right? 0.01 would be 1%, then 0.001 would be 1% of that. I think so. 0.1%? I'm not sure, but you get what's going on. Set current state. It's a game over. So our character died, so we're setting the state to game over. Yep. But we have to create the set current state though, right? We'll do that in just a second. I think right now we're going to do gameplay state ACPP tuts game mode, get current state. It's going to be a constant, and we're going to return current state. Void a CP tuts game mode. Handle new state. And we're going to do a switch case. So on handle new state, we're taking a new state, so if that new state equals one of the cases below, Run that function. What do we do? Okay. Curly braces. So if we're playing the game, I don't have any logic to do, so we'll just say do nothing. We'll do nothing to break out of it. Then case E gameplay state E is E game over. Oh, I think I need to put a colon up here. My fault. There we go. That's right. Yeah. All right. So if it's game over, we're just going to restart the level. An open level. Yeah. U gameplay statics open level. We're going to be referring to this actor, and then we're going to get the name. Point to get world, and we're going to get the name from the world, and then false. I'm not sure what that parameter is. So that's just going to restart the level, and we're getting the current level's name, and then we're reopening it. We're going to break out. And then default, whatever. By default, just the case is unknown. We're going to probably just do nothing, because I got nothing to do there. Unknown. Gameplay state, unknown, is that correct? Okay, so that should be it for the game modes. Let's go ahead and compile, see if there's any errors. Let's see if we're okay. Alright, we got some errors. They shouldn't be too hard to fix. Missing new class. So I'm just missing a semicolon. Yeah, a semicolon after the curly brace. Let's see if that works. Alright, it's at least going to continue running. Or running the compile. Alright, we got a bunch of errors. Semicolon. Yep. Gameplay statics is not a class or a name tag. Gameplay statics. It's a lowercase p. I think I'm inconsistent in my word gameplay, so that's kind of my fault. I think gameplay is one word and you should always lowercase p. Mod is not a class or a name tag. It's game mode, not game mod. FName, it's incorrectable. An E at the end. It should be successful. Spoke too soon. Reset the current state. Yeah, we missed the function. And that's set current state, I believe, right? That's gonna be void Cpp touch game mode set current state gameplay state new state. This is kind of directly from Epic CPP battery collector tutorial, so this is very, very similar. That's where I pretty much worked it from. Current state handle new state current state. Now let's compile. There we go, a successful compile. Alright, so that should be it for the game mode file. Alright, next let's jump into the HUD script. So I think I'm in the CPP one right now. I'm going to close out everything. Alright, jump to the header file for your first person HUD. And let's make it happen. We don't have to include anything. Let's include begin play here. Virtual void begin play override. They're using a crosshair already. What do we need? We want to do uProperty. Edit anywhere. Category, add it to health. It's going to be a T sub class of a capital O, lowercase f, class user widget. It's a U user widget, so 2 U's. And it's going to be a HUD class, HUD widget class. We're going to call it HUD widget class. I know the uProperty, edit anywhere. Category health. Shit. It's gonna be a class U user widget, a pointer, current widget. Alright, that should be it for the header file. Let's jump into the CPP file. In the constructor, we're going to do the same thing they're doing with their crosshair, but we're going to get our user widget that we'll create later. Health bar object. They have it called crosshair text object. I'm going to call it health bar object. It's going to be a U user widget. Constructor helpers F object finder. This is going to be F class finder. What else are we going to do? We'll set the location for it. Where are we going to put this thing? Let's just create it right now. I'm going to create a new folder. How do I do that? New folder, call it UI. I'm going to create a new user interface, which will be a widget blueprint. And we'll call that as health UI. So the location for where our user widget will be, game first person UI health UI. And then we are going to set not this again, but we're going to do the head widget class. And that's going to equal health bar object dot object or dot class. So it's going to be health bar object dot class. There we go. Draw HUD, we're not going to be there, but rather in begin play. Maybe we can do it in draw HUD, I don't know. Cpp tuts. Colon begin play. super begin play. If we successfully got our HUD widget, HUD widget class, if that's not null, then we're going to set our current widget, create widget, user widget, get world, HUD widget class. If it was successful, we're going to add it to the viewport. Okay, and that should be it for our HUD code. Let me save all, compile. Got some errors, let's see what they are. Create widget undefined. What are we doing? Is that a misspelling or what? Oh, you know what? We forgot to include some files up at top. Include blueprint user widget. That header file. Let's see what happens. Alright, that was successful. Let's get out of that. I think next thing we're going to do is we're going to create our actor that hurts, that will apply damage to the player. Alright, so let's go ahead and create a campfire. C plus Cpp tuts. Alright, right click, new C class, actor, and I'm going to call it campfire. Alright, awesome. So I just created the file for us. Campfire. What are we doing under? We want to add particles, so we're going to include particles slash particle system. .h. Anything else? We're going to add a box component to this as well. Include components, box component.h. Let's shut them down into public. We're going to get rid of the begin play function, and we're also going to get rid of the tick function. We don't need them. U property edit anywhere. U particle system component. We'll call it fire. U box component pointer my component. Or I called it my box component. What's next? The character, because I want to check to see if I'm overlapping with the character. It's going to be AActor pointer my character. And my hit result. Right, FHitResult equals my hit. Bool B can apply damage. timer handle. Create a U function. It's going to be void on overlap begin. Overlap begin. There's going to be quite a few of these, so let's do them. Some parameters. Class UPrimitiveComponent. You know what? Let me just copy them so I don't have to redo it. Much easier. We'll do void on overlap end. I'm gonna copy those parameters too. So those will be the two functions for when you overlap the fire and when you end the overlap on the fire. And that's just going to toggle bools and also toggle the hit. Or also the toggle the apply damage. Alright, U function void apply fire damage. This apply fire damage is separate from the apply point damage step, rather. So that's it for the campfire header file. Now let's go into the CPP file. We don't need the begin, play, or the tick functions, so we'll get rid of those. What's next? Alright. So one, we need the Kismet library, the gameplay statics library, because that's where we're going to get apply damage from, I believe. So include Kismet. Gameplay statics.h. Oh shit. Include timer manager. So although we have a invincibility on the character, we're also going to trigger the hit after every 2 seconds or so with the fire, because since it's an overlap hit, and not a blocking hit, the overlap doesn't always fire. It kind of just fires once. So we want the timer to routinely loop and fire a hit every time the fire can apply damage, every time its bool is set to true. So we'll get to that in just a second. That's just a quick overview on it. We don't need this because again we're not using tick. Let's set up our fire, our campfire. So FComponent, or my component, equals create default subobject box component. Oh yeah, my component's wrong. It's called my box component. My fault. We're setting how big the box should be. I'm doing 50 by 50 by 50, so should be a pretty generous hit location. Then we're gonna also set it to the root component. Root component equals my box component. Fire is our particle effect, and we're gonna create default subobject. It's gonna be a particle system. My fire. set relative location. Just making sure it's placed in the center. Setup, attachment, and attach to the root component. Now we want to bind the overlap functions, so it's my box component. Begin overlap. On component end overlap. Add dynamic campfire on overlap end. And by default, this cannot apply damage. B can so that's it for the constructor. Let's do our overlap function. Void a campfire on overlap begin. I'm going to go back to the header file to get the signature. No, on begin. Let's set up the logic for it. Alright, if we'll do our error checks and other actor doesn't equal this, and other comp. Alright, so yes, we are overlapping, so that means we can apply damage. Right? B can apply damage equals true. My character cast actor, other actor, so my hits, that's taking the overlapping hit result that we get. So get world timer manager. Did we include that up top? Yeah, we did. Get world timer manager. We're gonna set the timer. Fire timer handle. This, and then reference a function we'll make later. A campfire, apply fire damage. We're gonna do it every 2.2 seconds. It's a little more than 2 seconds, so we don't conflict with the invincibility 2 seconds. So there is a buffer. void mcampfire on overlap end. I'm going to go back to the header file, copy the signature. Set B can apply damage back to false. Get world timer manager. We're going to clear the timer. It's not needed anymore. Fire timer handle. I might have missed something in the header file. Go back to the header file. I'm going to create a default damage type for this guy. It's really just a placeholder parameter. You can do a lot with damage types, but for this one, we're just gonna pass it through. Kind of just pass it through and not do anything with it. But it's a necessary parameter for the function to run. Of UDamageType. I'm gonna call it fire damage type. Okay, back to the CPP. Apply fire damage. If B can apply damage. So apply point damage, this is what's triggering the receive point damage function on the character side. Oh, we're going to do it to him. This is how much damage we're going to pass through. We're going to pass through 200 points of damage. Right now my character's full health is set at 1,000, so it's 20% damage. Get actor location. This isn't really that important, but it's just in case you want to trigger on where the damage came from. My hit, just passing the hit results. We don't need anything for this parameter. We're targeting this actor, and the damage type is fire damage type. Again, we're not doing anything with that parameter either. The main thing we're dealing with is just damage, but the other ones are very great parameters that we can use and make more complex damage logic with. Semicolon, that should be it for the campfire. Let's see if we can make it happen. We'll compile it, see if there's any errors, and then move from there. Alright, let's clean it up. Text identifier not found. Alright. All caps. Actor 30. Oh, it should be AActor, right? Yeah. Let's compile and see if we can narrow it down a little bit. Cannot convert uParticle system to uParticle system component. Yep, that's correct. uParticle system component. Get world time manager. Alright, what's this one? Get world timer manager. Oh, we're misspelled, right? So increase that M and add an A. There we go. Non-standard syntax. Alright. Oh, we don't have a comma there, right? Yeah. Alright, compile success. What's next? I think we make the Medkit next, and then we'll be done with the code, I believe. Right click, new C++ class, actor, call it Medkit, create that class. Alright, what are we doing for the Medkit? Again, we're getting rid of the begin play function. We're getting rid of the tick function. We're going to run some quick overlaps. Void on overlap AActor points to my overlapped actor, comma, another AActor equals other actor. This is a much quicker way to do overlap when you're not using a sphere component or a box component or any other type of thing you want to trigger components on. This event is a delegate that will connect that or overlap whenever you overlap with whatever the object is for what this actor is. And we'll just add in a mesh and it'll be that simple. U property. And it doesn't need to end overlap either because nothing will happen on end. We're going to destroy it. A Cpp tuts character pointer my character we need to add this header file. Cpp tuts character.h. Alright, jump into the Cpp file, Medkit Cpp, no begin play, no tick, get rid of that. What are we doing? Let's set up the event delegate on actor begin overlap, add dynamic, this reference Medkit on overlap. Void a Medkit takes in two actors as parameters. My overlapped actor, actor again, other actor. Let's do some error checking. This. Let's cast. My character equals cast to Cpp tuts character using the other actor. If my character. So assume that that's true. We will then run the next function. I don't believe that the second function, the second part of this conditional logic should not run if my character is false. We're going to get health, see if it's less than 100%, because you do not want to pick up a health kit if you don't need it. We're going to run update health, capital H, and we're going to add just 100 points of health back to the character, and we're going to destroy the actor. Let's save, compile, and see if we're done. Alright, let's clean up the errors. Oh, fuck. Oh, it's a Medkit, I believe, because it's an actor. Cpp touch character and cloud identifier. It's a Cpp character because it's an actor again. Alright, I think that should be done for the C++ code. We'll now jump to the UI, connect that, and hopefully get this thing over with. But who knows? Alright, let's go ahead and start by creating the timeline that we'll use for the magic curve. Create it wherever you want in the content folder. Right click, miscellaneous, float curve, float curve. We'll call it magic curve. Double click to open. Right click, add key to magic curve. Time is 0, value is 0. Add another keyframe. Time is going to be 2 and value is going to be 1. Auto, fit vertical, fit. Shift select, so I have them both selected. Auto, that will give us a smooth timeline. Save. So let's compile it. No, I saved it. Get out of it. UI, we created this earlier, so let's go into our UI folder. If it opens, there we go. Let's go ahead and get our assets. Have them in my desktop. These assets will be provided in the description below. All 4 of them. I'm just gonna go ahead and drag all 4 of them down. They're imported successfully. Get out. Since I already have them all selected, I'm going to right click, sprite actions, create sprite. So now I have 4 sprites. Alright, now let's jump into the health UI. First things first, let's drag in the progress bar. Make it a little bigger. I know how big the images are, so we're going to set the size of the progress bar to that. It'll be 419 by 55. We're going to set the background image to the empty health bar empty sprite. Then we're going to set the fill image to the full health bar full sprite. Percent, let's just start at 0.75 to see a change. Right now we're not seeing anything, so let's go down to fill, color, and opacity. Let's go ahead and change everything to 1. Now click OK, and now we have kind of that red effect. So we can test out. 100, you get the full bar. 0, you get an empty bar, and then everything in between. Let's go ahead and bind this percentage, or we can do that at the very end. Well, let's go ahead and just finish our UI. Drag in another image. This will be the Witcher symbol. What's the Witcher symbol dimensions? 123 by 100. Okay, where do I set the image? Somewhere in here, right? Render, transform. Fuck, where is it? Appearance, right? Brush, set the image. Oops. Type in a symbol. I think I called it Witcher symbol, right? Get the sprite. There we go. Put that nicely in the corner. We can move this anywhere we want. Put that back in front. Drag it down a little bit more. Well, that should be good enough. Let's drag in a second progress bar for the magic. This we're not going to use an image for, so we have a little bit of fun with it. All that sounds good. Background, that's fine. You know what? Let's make it black. No. Yeah. Fill color is going to be that. I was like 0.5. That's good. Border padding. Let's give it some padding. 2 and 2. Is everything else good? Give it a good black tint on the back. Do it a little bit lower. That should be fine there. Now let's add in some text. We have this text block here. You know what, let me name this real quick. Magic bar. This is health text. By default, it'll just be like 100%, something. Now we're dragging some more text. And default, this will be like 100 over 100. We have to decrease this font by a lot. Where's font size? Font. Let's just go with 15. That should be fine. Can we change the color of it? We can make it kind of a blue. There we go. Okay, so now let's go ahead and bind these UI elements to the respective C++ functions. We're going to do this in blueprints, and we'll jump in and jump right out. It's probably as simple as blueprints will get, but let's do it very quickly. This is my health bar. Where's the percentage at? Click bind, create new binding. That's the return node. So the first thing we want to do is get player character. Right click, get player character. Next thing we want to do is cast. Cast to your character. Mine is called Cpp Touch Character. Right click to make it pure. And now from here, we're going to run the function get health. You can already see that get health in, and that will respectively be connected to the UI's text. Get health. And boom. Save, compile, and then that's it for that node. Get out of that. Go back to designer. Now we're going to do it for the other three elements. For this text element, text, we're going to bind it. Get player character. Cast. Cast to C++ test, and this is right click, convert to pure. And that's going to be get health. I'll just say get health int. And success. Save, compile, go back to designer, do it 2 more times. This is for magic. Go down to your percent. We're going to bind it, create binding. Get player character. There we go. We're going to cast it. Cast to Cpp Touch Character. Right click to make pure. And this is going to be get magic, right? This is the percent bar. Get magic. There we go. There we go. Compile, save. Designer. We're going to go here. Where do we bind it to? No, we don't need color binding right now. It's really helpful. Yeah, we get to we could bind a lot of stuff to our CPP functions. Bind, create binding. Get player character. Cast to Cpp Touch Character. Right click to make pure. And then we're just gonna do the get magic in, right? And then boom, I'm gonna save, compile. Is there a save all? Yeah, save all, why not? Are they all compiled and ready to go? So that's very cool. And this event graph we'll touch in just a second. Let's go back to the designer and let's try again another image. This image right here. What can we do? Anchors, I'm going to create the full anchor right there. I believe that means it should fill out the entire screen. We'll drag it out. So again, this anchor should mean that it covers the entire screen on all resolutions. The image that we need though, we need the red image. And so we'll do the red flash that we're doing, indicating that we're being hit. Take the red sprite. Very cool. Where's the alpha at? Alpha, go ahead and change that to 0. So now we can't see it. Now let's create an animation. You could probably do this from binding, like doing a timeline or a lerp or something like that. If you bind the alpha function to a CPP function, that'd be great. Or the the RGBA value to a C++ function, that'd be great as well. But for examples and for practice, let's go ahead and make an animation. I'm gonna call it flash. All right, how do we do this? Dude, what do I do? Yeah, red image. I'm gonna call this red image so I know what the heck it is. Then we're gonna track the red image. Track, and we want the color and opacity of it. So cool, we're gonna start at 0, then at 0.5, we're gonna change it to 0.5, and then we're gonna move this along, change it back to 0, move another ½ second, change it back to 0.5, and then after 2 seconds we're gonna go back to 0. And that's our animation, right? So see that little flash? Let's go ahead and play it. That's all, right? It's just indicating that we're being hit. Now we want to jump into our graph. We're going to run this on the tick function. So we're going to do the same process as always, or as we did previously. Get player character. We're going to cast. Cast, use CPP test character. Right click to make pure. Play flash. That's the function that we made. Play flash. We're also going to branch off from tick. The branch is Blueprint's version of an if statement. So if play flash is true, because again, this function returns a bool, so it'll return true or false. So if it's true, we're going to play animation. Play animation under user interface, animation, play animation. Now we need to connect this animation to the one we just created. So if we go in our variables on the left hand side under animations, we have flash, drag it in, get flash, and connect it. It's in animation. And that's it, right? So there's not a lot of blueprints going on, but again, these blueprints, that's it for now. As far as blueprints goes, yes, there's probably definitely ways to do it in C++, but I'll probably have to visit that later. So I'm going to compile, save, get out of UI. Now let's set up the character, right? So we click on the character and we add some values to them. So let me go ahead and search for them. I just typed in magic. We have this magic curve, right? This magic curve, we want to be the magic curve that we created. There we go. We also have default materials. So the gun default material, I don't know what it is it just called gun or something? Yeah, that's the default one. Let's create a glowing one, right? Where are my materials at in this thing? Go back to first person. Materials. Let me go ahead and copy the basic floor. Duplicate. I'm going to call it mRedGlow. Open that thing up. This is blueprints, sure, as well. We're going to change that to red. What's a good red? There we go. We don't need roughness. We can bring this thing out, right click, multiply. Get that. Change this value into here. Change this value into here. Let's go ahead and click into this variable and make it 50. And Alt click to get rid of that. Alt click to get rid of base color. And now this multiply function will go into emissive color. And now you can see we have a very bright, shining, glowing red. Apply, save, get out of that. So that's going to be my overheat material. Oh no, I called it red though, right? Red glow. Alright, I think we're getting closer. C++ class. Campfire, right? The thing that's going to do our damage. You can see that this is the box component that if I interact with that, I'm going to get hurt. Get out of here. Fire. Template. Just look for fire. We got the explosion right there. What do we want? We want the fire, right? Yeah, there we go. So here, so if we interact with it, we'll get hurt. And now we need the medkit. Let's drop in some medkits. Ooh, there's nothing there. We want to add a cube component. There we go. I kind of know some good scale, so I'm going to do 0.25, 0.25, 0.5. Oh, you know what? I did it. I think it should be 0.5, 0.5, 0.25. There we go. Now it's kind of a good rectangle. Yeah, I think that's all I have to do. You can change the materials, of course. Change the mesh, of course. One, I'm going to click this this thing. Click on this overlap. So yes. No, let's just click include. Generate overlap events is true. Let's type on collision. We're going to our collision presets. We don't want to block everything. We just want to set it to a trigger. There we go. We want to do the same thing with our fire. I can't fire one. Where are my collision presets? Again, on their collision presets, we don't want to block everything or overlap everything. We just want to do similar to a trigger. Those are good presets. Alright, so I fixed a couple of my errors. One error I think I had was when we go into the red glow, instead of just going off to emissive, I then went ahead and dragged off into base color as well to make sure that the color, that the gun does have a color or something. You know, I don't think I had to do that in the past, but now I have it there. I believe it's working now, so we're almost good to go. So let me apply it, save it, get out of this material, and then my receive damage function. I changed the signature to what I had in my test. So I just went ahead and went to the repo, copied what I have, pasted that back into the header, did that for the header, and the Cpp file. Where is it? Receive damage. So now those signatures match. They're a little less specific, I think. I'm not sure. But anyways, we should be firing now. So let's jump ahead into the game. Shoot. We are changing colors. We are decreasing our magic. Now let's get hit. Hit. Our animation plays. It continues to play because our fire keeps on hitting us. And now let's get our medkit, and it goes up by 10%. So that should be working. Thank you so much for watching, and I will see you.